Okay, so this is the Open Smart Focuser. All the 3D printed parts are revision 0.9. They're not full release because I don't have the printed circuit board, unfortunately, due to stuff happening in the USA. Getting a PCB manufactured is a absolute pain in the you know what. So I threw it together with a perf board. The firmware is all custom built. We have a nice little star chart here. This will show idle and this will update. I'm still working on the Indy driver and the ASCOM driver as well, so it's not updating immediately right now. But, and I really hope it's on the fast mode. You can just barely see it move. If you look at that, it has a 1 to 23 reduction and then the reduction of the lead screw, so it's very fine with movements. To kind of demonstrate it, I'm just going to quickly go into here and I'm going to have it run homing. That will have it move as fast as it can. So we have an end stop here that is used for figuring out homing, obviously the lead screw, NEMA 11 for movement. Inside we have our worm drive, which rotates the nut about the lead screw. The lead screw is stationary, and then 2 linear rails, one on each side, and that allows for everything to move nice and smoothly. We have a nylon nut or thumb screw and nut to fix your camera so that it doesn't get marred. And we have this little opening for the main board, which I'm still designing. So for right now, it works. I have a very basic Indy driver that is working. It's about to be done with homing. So I'll just stop right here, showcase that. There we go, so now it's homed. On the software side of things, this is something I'm most proud about, is we have presets. You can add up to 12 presets. I have some preset names. If you're using the terminal to communicate with it, you can set whatever you want for the names. I also have some test positions, but like if I go to my clear, which is actually my test focus position, I can hit go to. Oh, hit the wrong button. And it's moving. And if I go back to the main screen, it says homing, it should say moving. Once again, I'm still working on the firmware, drivers, all that, but you can see here it's moving upward and it will go to that saved position. One thing you might have noticed is this port here. This port here is for a shutter expansion. The shutter will be controlled by just a standard servo, and it will also have a flat panel. So in there, those 4 pins, we have 5-volt ground, LED signal, and servo signal. Right now, those wires are just tucked up there because they're not needed right now. I haven't had the servo come in, and so I'm still designing that. So now you can see here, it's at 26 millimeters. It's been moving. Every time a move is commanded, this includes focus pulses, pretty much any time the motor is touched, it saves its position to non-volatile memory, and then once it boots, it will load that. There's not a way to physically move the focuser outside of digital control. That can be seen as a downside, but for the sake of board space in here, while you can, if I can move these wires out of the way, you might be able to see the auxiliary shaft port. There we go. Let's see. Come on, focus. There's the auxiliary shaft. I did have a version where there was a knob there, but having a pass-through hole in the PCB made some problems with fitting everything on the PCB. Basically, because the PCB includes the ESP32, the LCD, the buttons, the TMC 2209, and 12 volts to 5 volts to 3.3 volts. So it's a lot to go on the board. I ended up going with 2 sandwich board designs. The main power board will sit right back here. That's the hole for the power connector. And then the rest will have the main board just right on that front face. Another expansion that I have is some additional sensors that would go at the bottom of the optical tube assembly, as well as 3 28 BYJ stepper motors for collimation. So those all run off of 5 volt and off of an I2C extender. So I'll just have a nice little I2C port right here that will run all the way down the length of the OTA to the rear, where the I2C extender, Darlington arrays, and stepper motors would be for those. Those are only for like fine adjustments on the primary mirror collimation. You would still have to do secondary mirror collimation manually. And I'm working on writing a driver that will take an image from Indy when it's out of focus and manually do those adjustments so you have a nice perfect collimation every time. So yeah, this is Open Smart Focuser. I have a variety of pins that are not exposed on the ESP32, so there's potential room for growth. Like I said, I'm still working on drivers, firmware, and printed circuit board. So, yeah,